The activity aims to impart the standard preparation of disturbed soil samples. Intended learning outcomes. The students shall be able to prepare disturbed soil samples for future laboratory experiments. Distinguish unacceptable practices in preparation of soil samples. The method of dry preparation of soil samples is used to prepare soil samples in various laboratory experiments, such as moisture determination, particle size analysis, and in determination of Atterberg limits. It is proper that the samples be prepared in an orderly manner to avoid compromising the results of the laboratory experiments because of errors in the preparation proper. Preparation also will allow sufficient amount of samples for each laboratory experiment. Resources. 1. Triple beam balance. 2. Oven with temperature control. 3. Pans. 4. Standard sieves #4 and #O. 5. Rubber mallet or rubber covered vessel. 6. Mortar and rubber vessel. 7. Trowel. 8. Sample splitter. Allow the soil sample recovered from the field to dry roughly on room temperature. Using a mortar and vessel, break up the aggregations thoroughly. Select about 75 grams of the sample for the conduct of moisture content determination. Separate the test sample using sieve No.10. Break up again the soil fraction retained in sieve #IO to break the grains thoroughly. Separate again the grinded soil into two fractions using sieve #10. Determine the weight of the fraction retained in sieve #10. Wash the soil fraction of all fine material, dry and weigh. Record the mass as the mass of the coarse material. After being washed and dried, sieve the material using the sieve NOT4 and record the mass retained. Thoroughly mix together the soil fraction, passing sieve NO.10 on the previous sieving operations. Using a sample splitter, select a portion of approximately 1209 for the particle size analysis. Select a portion passing sieve #40 of approximately 200 grams in determining the soil constants. Here are our observations of each particle size analysis from borehole 1, 2, and 3. Each soil samples have their own description based on texture, color, smell. Most of them have dark brown, clayey, and earthy odor, with some having silty, light brown texture. This is the table under soil constant. This table illustrates the visuals of soil under a certain weight. Most soils have the brown, clayey to silty clay and earthy odor, with some soil having a sandy texture. The systematic dry preparation of soil samples from the 3 boreholes provided a reliable basis for observing and testing soil characteristics. Overall, the soils were composed of clay, clayey, and silty clay materials with an earthy odor, showing variations in color, texture, and moisture content at different depths and locations. These variations reflect changes in soil composition and consistency, which are crucial for soil classification.